Let's use the empirical rule for the normal distribution to estimate probability. Now, hopefully you remember a little bit about the empirical rule, but if not, the mean is in the middle. And we know that 68% of data falls within one standard deviation of the mean. So that means each one of these is 34%. And this is consistent within the empirical rule. If I go 2 standard deviations away, that means 95% of my data is within 2 standard deviations. So with the 68% already in the middle, we've got 27% left over. And you divide it by 2 because this is symmetric. So each chunk is 13.5%. If I go one more out, that's mean plus 3 standard deviations. This is what's usual, between 3. Well, from 3 to 3, that's 99.7% of data, which means 2.35% is in each of these chunks because 95% was already discussed. Now, the entire normal distribution curve is 100%, right? It's all. And we have 99.7% already accounted for, which means we have 0.3% left. We're going to divide that by 2, and we're going to put 1.15% in each of the wings. Now, this is consistent with the empirical rule, and I highly recommend you draw pictures when you're working with this. So we know the mean is 62 and the standard deviation is 3. What range of values holds 95% of the data? Well, if I'm drawing myself a distribution curve, and I know the mean in the middle is 62. Now, 95% of the data is within 2 standard deviations. So 1 standard deviation, I'm going to add 3. So 62 plus 3 is 65. To get the next one out, I go again, and I'm going to add another standard deviation. 65 plus 3 is 68. So that's one of them. Well, I got to go the other direction as well. So if I go left, I'm subtracting a standard deviation, so I get 59. And then I'm going to subtract another one because 1, 2, right? I'm going to subtract another, and I get 56. So here's the other one. So 95% of data is between 56 and 68. Based off the empirical rule. Next problem, we know that the mean is 18 and the standard deviation is 1.5. What is the probability a value is less than 19.5? Okay, well, again, let's draw ourselves a picture. We know the mean is 18. Standard deviation is 1.5. Now, 19.5, is larger, so we're going to go this way. So I take 18 and I add 1.5. There's 19.5. So this is the spot in question. Now, it does say less than that. Well, less than is to the left. So I want all of this. How much is this? Well, remember that, oops, wrong button. 68% of the data is within 1 standard deviation, right? So this is 34%, as is this. But try not to make this too difficult for yourselves. We know that the mean splits this in half, right? So from the mean to the left is 50% of your data. So I can say, well, I've got 50% plus 34, which gives me 84% of my data is going to be less than 19.5. Now, if I just lost you there, don't worry, I'm coming back. We know that 34% is there, and if you do another one, you're at 13.5, and another is 2.35, and the wing is 0.15%. If you don't understand the mean splits it in half, then just add all of these together. You're still going to get 84%. So you can have your picture of the entire empirical rule, and you add up the probabilities that you need for the particular problem. Let's do one more. Well, actually 2 here. The mean is 46 with a standard deviation of 3.5. Part A, what's the probability a value is between 39 and 49.5? Well, first, let's draw our picture. And let's get this in here, okay? So my mean is 46. If I add 3.5, I'm going to get 49.5. If I add 3.5, I get 53. I get 56.5. Okay, let's go the other direction. If I subtract 3.5, I get 42.5. Subtract 3.5, I get 39. Subtract 3.5, I get 35.5. Okay, so I have my numbers here. So now that I have those, let's look at part A. Oh, wait, let me put my percents in. Please excuse. So 34s, I've got 13.5%. Oop, that's a 5. 2.35% and 0.15%. Do it the other way as well because it's all about symmetry, which is nice. You only have to really remember one side, and then you can make it work for both. Okay, now we can do part A. Part A, that says between 39, that's here, and 49.5, that's here. So 13.5 plus 34 plus 34 gives me an answer of 81.5% for part A. All right, we just add them together, and that's it. This makes the empirical rule easy, really easy to work with. In part B, probability of value is greater than 49.5. Okay, so 49.5 is here. Greater means to the right. So I'm looking at these three values. So 13.5, 2.35, and 0.15. And that gives me 16%. So it's nice, but the empirical rule only really works if you are right on these values. So if you said, well, what's the difference? What's the probability to go from 50 to 55? Well, that's like from here to here. Nobody knows what that is. So you have to use different methods if you want to find values that are not on the standard deviations from the mean. So this is very much an estimate of probability based on the mean and the standard deviation.